if I start with the standard form of an ellipse, x squared over a squared plus y squared over b squared is equal to 1. This is using the rectangular coordinate system here. I have an ellipse centered at the origin. I have a point over here called the focus, which I label as f1, and this is the point negative f0. I have another point over here, which I'll label as f2, and it's at the point f0. I have the extreme of what's called the major axis at a0 and negative a0. And then the minor axis, this one right here, goes from 0b and 0 negative b, the bottom of this semi-minor axis, or of the minor axis. And I have some point here, x, y. From here to here, d1, from here to here, d2, and as we've established in another video, and just basically definition of an ellipse, d1 plus d2 is equal to a constant, and that constant is 2a. And in another video, directly connected those two equations. So now what I'm going to do is I'm going to put this into polar form, and I'm going to shift my coordinate system from 0, 0, from rectangular form. I'm going to shift it over to this right here, to this being the sort of central figure, and I'm going to put it into polar form. So if I look at, if this is now my reference right here, well, my y is still the same, but my x is different, so I'm going to label this as x prime y. So where x prime is the distance, is that distance right there. In other words, x prime plus f is equal to x. And so this equation now becomes x prime plus f squared over a squared plus y squared over b squared equals 1. I'm going to multiply by a squared b squared. And to get rid of my fractions, so I have b squared times x prime plus f squared plus a squared y squared equals a squared b squared. Now x prime here, if I think about that triangle here, since I'm putting it in polar form, I have some angle here, theta. This is x prime y. In other words, that length there is x prime, that length there is y, and this distance here is d2. Or since this is my reference point here, not only is that d2, but that's going to make that some distance r. So if I'm over, so no matter where I am, r is the distance from my new origin. So x prime is just equal to r cosine theta. So I have b squared times r cosine theta plus f squared plus a squared y squared equals a squared b squared. Oh, y, that's going to be r sine theta. So I could have made that substitution last time, but didn't. Oh well. R cosine theta plus f squared plus a squared r squared sine squared theta equals a squared b squared. So we're going to now square this out, and I'm going to go ahead and now we'll distribute b squared in just a second. So I have b squared r squared cosine squared theta plus 2rf cosine theta plus f squared plus a squared r squared sine squared theta equals a squared b squared. Now I need to distribute the b squared to each of the terms there, but also just to write less, I'm going to let c equal cosine theta and s equal sine theta. So distributing, I get b squared r squared cosine squared plus 2b squared r f cosine plus b squared f squared plus, so that is this bit right here, plus, well, sine squared is just 1 minus cosine squared, so I can distribute that. So this becomes a squared r squared minus a squared r squared cosine squared is equal to a squared b squared. So I've got a cosine squared term and a cosine squared term there. So let's go ahead and combine those and do a little factoring here. So I have b squared minus a squared, r squared cosine squared. And then if I bring this over to that side, I have, so left over here, I've got plus 2b squared rf cosine plus a squared r squared equals a squared b squared minus b squared f squared, which is b squared a squared, factoring that out. If we go back to the previous video, we had shown that a squared equals f squared plus b squared. So b squared minus a squared right here, this is negative f squared, and a squared minus f squared, this is b squared. And so now this becomes negative f squared r squared cosine squared plus 2b squared rf cosine plus a squared r squared equals b to the fourth. Isolating a squared r squared, so I have a squared r squared equals b to the fourth minus 2b squared rf cosine theta plus f squared r squared cosine squared. This is a perfect square, so that's a squared r squared equals b squared minus frc squared. AR equals b squared minus frc, taking the square root of both sides. So AR is plus FR cosine theta. At this point, it's reduced enough that I feel more comfortable writing it out. Equals b squared. Going to factor r out, so r times a plus f cosine theta equals b squared. And so r is equal to b squared over a plus f cosine theta. Now, we're going to define an eccentricity. So looking at this right here, just absolutely lovely picture of an ellipse. That distance is a, this distance right here to the focal point, f, and the ratio is, we will define as this new thing called E, because you can't use E too many times, eccentricity, which we'll define as the ratio of focal length to A, so that distance to that distance. So if the eccentricity is 0, in other words, f is 0, then we are dealing with a circle. The closer it gets to 1, then the more widespread out it gets. And so this becomes b squared, factoring a out of the bottom, 1 plus f over a cosine theta, which is b squared over a 1 plus e cosine theta. And so this is the polar form of an ellipse. And that is something that we will directly connect to orbital motion.